Hello, everybody. You survived lunch? You know that this is the hardest time for a presentation when people fall asleep after food? I will make sure you don't, believe me. So it's even hard for me, so nothing to complain. So welcome, my name is Carlos Heller. I'm the technical director of the DACH region. So I'm helping out here Beatrice, my colleague, because the SE in charge is on vacation. Not sure, did you sign it? Did you approve it? So I'm helping out. Unfortunately, my Hungarian is so bad, I don't speak a single word, so I do it in English until you tell me you prefer it in German. No? Okay, so we do it in English. So we're going to talk about security, Skybox security, and how and what we can do for customers, their networks, and what is our approach to make your company more secure. So basically, Skybox is not the new kid on the block, okay? We are 16 years old, so we are not a startup. Even we call ourselves a startup to cover our mistakes, right? We say, we're a startup. No, we're not. We're 16 years old, and we are coming out of the vulnerability corner. Some people, they put us in a different firewall assurance and stuff like this, but that's not where we're coming from. We're coming from vulnerability management. That was the first product we released in 2004. One of the terms I think we stamped in the industry is attack surface. I think that Skybox was one of the first to bring that in. What is the attack surface? It is a summary of all your vulnerabilities. Okay? Think about you have an ocean, and you have a diver, and he's breathing out, and you see all the bubbles are coming. Okay? The little bubbles on the ground, they're getting up, they're getting bigger and bigger and bigger, and that's the attack surface. Okay? On the Bermuda Triangle, you see ships thinking because of this. Hopefully not your enterprise. So that's what we call the attack surface. There's one hint why it's written in red. You're going to figure out at the end of the presentation why. So how do we define that? So basically there's a human attacker. And this guy can be anything, like it can be a hacker from the internet, it can be a corrupted insider, can be a business partner that has been hacked, okay, and you're connected to him. So what are the possible paths of this? It's malware, it's a direct attack, there's probably open ports you can use, and there's things calling back home, you know, all these different, let's say, insecurity attack methods. Then we still have the social engineering. Yes, it works. Believe it or not, social engineering in the security space still works. I had a very, very nice example last time. I was in a high security area. Who knows what tailgating is? Of course. It still works. I did it. I mean, and the guy asked me, how did you came in here? And I said, well, the door was open, right? So I just ran behind the guy, and it just woof, like this. So social engineering, we have software bugs, we have parameter devices which probably being misconfigured. People don't understand the behavior of the device. I'll give you an example. We had a customer in Switzerland, and I did a POC with him. So we installed the solution, and it was a specific firewall vendor, I'm not going to mention the name, and we imported it. It was a perimeter firewall, okay? And out of the sudden, we could see that there was a default admin on the config. So we looked for this, okay? And we said, why is that the case? And the customer said, I don't know. So what we figured out, there were two admins, the one he's using on a day-to-day business and the default admin. The default admin was deleted previously, but the device broke. They did a hardware RMA. They replaced the hardware. They brought in a new one. They put the old backup file on top of it. What they didn't know is if the config file version is different from the OS version, you're putting it on, this specific firewall vendor leaves the default admin. It puts it in the config while you copy it over. It puts it in during the restore process just to ensure that you can log in case they change the encryption algorithm for the stored password, which makes perfect sense, but you need to read what? The release notes. So all of this stuff we are looking, and we try to reduce the access and security methods people use to penetrate your network and to get your data. So there are a couple of breach methods and a couple of things we try to help you out. The first thing is, surprise, no vendor is perfect. Every software and every hardware made by humans has holes, has mistakes, has, let's say, pinholes to penetrate it and to leverage from this in terms of a break-in. Device misconfigurations, we're all humans. You got this example right now. One of the biggest burdens we have when I talk about Skybox is that people don't believe that machines can do a lot of things better than humans. Okay? When you need to configure a firewall rule or you need to configure a specific thing on a firewall, machines can do that much better. We call this automated provisioning, rather than people doing it on the day-to-day business, because they make mistakes. They had lunch like you, fall asleep, you know, party last night, typos, whatever, okay, stress with the girlfriend. So, lack of automated solution. They're afraid to implement this. People are afraid to lose their job. People are afraid to give away responsibility, okay? So the next thing we see is that I can't really remediate all the vulnerabilities. We must prioritize this. And one of the next slides will tell you a shocking news, okay? And then we have, of course, lack of contextual information, no single source of truth. You do have an asset system, you do have a CM solution, you do have a vulnerability scanner, you do have your firewalls, you do have all these entities, right? Do they talk to each other? No. Right? So that's what Skybox tries to do. It tries really to pull this information from all of these devices, okay? Combines it in an engine and then tries to generate more data, not new data, but more data, more valuable data just for you, okay? To make your company more secure. Broken processes. Okay, today you have something like this, okay? You have your security department, they scan the network, they get an exploitability list based on severities and stuff like this, okay? That's all fine, it's business as usual, as you do it today. What you then have is operations. Operations is supposed to patch the system here, okay? Operations is supposed to do that. And there's something in between, the I don't care firewall. Okay? Believe it or not, it is the truth. Because this guy here, he did his job. His job description is scan the devices every day, month, week, whatever, deliver a report. He does. Okay? He gives it to OT or IT, whatever it is. Okay? Does IT have a clue how to patch the system? Sometimes yes, sometimes no. Do they know how to prioritize? Probably not, because they have something like 30,000 vulnerabilities a day. You go, okay? That's it. And so what we see in reality is, that's the vulnerability count over year. Replace this number with your number in your organization, it doesn't matter. It's not an absolute number I'm going to talk about. So what you see here is the vulnerability count, and that's what you do. Severity remediation. You remediate your vulnerabilities based on the severity. Hands up, who's doing that? Everyone, right? Don't be afraid. Are you getting any better here? Do you see an improvement here? Not really, huh? What did Einstein say? Who knows it? When you do the same thing every day in the same way, how can you expect a different result? So you're not going anywhere. That's what you should do. You should do a risk-based remediation. You should look at what is important for me and for my company, and not what is important for the vulnerability. Of course, that goes in here, right? I mean, the criticality, exploitable in the wild, blah, 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 blah. But in fact, it should be important to your company and not to according to the vulnerability. And then the process looks a little bit different here. So basically, we try to collect this, same before, okay? And then we try to give, first of all, prioritized vulnerabilities. You would see later on in the presentation how that looks like. We prioritize, based on an algorithm, we prioritize the stuff and give it to the guys. We give mitigation options. When you know what's broken, do you know how to fix it? Probably not. right? I mean, think about, I'm a piston head, right? I mean, I'm deep into cars. So think about this. You hear your engine making like, you open it up, you see there's no oil in, so you know probably what has gone wrong, right? So you need to put oil in, probably the engine goes running again. But does the IT department know that? Probably not. They probably know about the vulnerability, they probably have heard about a patch, but does that really make sense? No, what you want is first of all, that they look into it. Is there an IPS signature I can deploy in my network in front of the data center to protect 2,000 servers at once? Or do I want to do what? Upgrade and reconfigure this stuff on 2,000 servers. So you want the best solution to prevent this vulnerability to be exposed, rather than to go the old way down to patch every single server at once, okay? So that's not what you want. So then, of course, we have the prioritized patching. Okay, if that doesn't work, IPS signature, firewall security, yada, 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 you're going to give the guys an idea. This department gives the guys an idea how to prioritize, and all that information comes out of Skybox. Okay, and how to prioritize the patches. If there are 2, 3, 4, 5, 6, 10 patches from Microsoft, which one is the best? So we give you an idea which one you should use. What's the secret behind it? How are we going to do that? We built what we call a queryable infrastructure. So basically, we read in everything from your devices. So it doesn't matter if it's a firewall configuration, router configuration, it doesn't matter if it's an IPS system, if it's an asset system, it's your vulnerability scanner, the result out of your penetration tests. So we collect that data, okay? We have 120 vendors currently we're supporting. So we collect the data. We built this. We built this here, the infrastructure. We know the network, and you can query it, actually. You really can query the network based on source, destination, and ports. And then we get the repository stuff, homegrown databases, patch management, endpoint security information. You probably have McAfee or Symantec installed. We read the EPO in, okay? We do the same with the CMDBSs or CMDBSs. After this, we map the vulnerabilities even without having scan results. So what Skybox does is we have an own department that collects vulnerability information based on different sources. From the scanner vendors, from Microsoft, from Cisco, from Adobe, all these bulletins. They all go into what we call a dictionary, okay? This dictionary sits in Skybox, and it looks, basically there's a task looking into all what we know here, okay, about your asset, about your networks, and then we compare, like there's a Windows Server 2013 is actual, I'm a Mac head, I'm not sure about Windows. Windows Server 2013, there's whatever kind of service, Oracle installed. The dictionary is being downloaded once a night, and it says, well, there's a new vulnerability for Oracle. On your desktop PCs, your IT department deploys Adobe, okay? And 2 days later, we figure out for that specific version of Adobe, there's a vulnerability. So we send that down with the dictionary, and we have a task comparing software version, OS version, and the combination of the applications being installed on top of it. And then we can tell you there's a vulnerability, and then we can map the criticality against it. Because we have something we call the business factors and business values for your assets. I'm going to give you an example later on what that means. And then, of course, we have these public feeds we can use. You can use, as I said, dark web solutions. We can add other scanners and app feeds like the Symantec, NetWitness, whatever there is, okay? We can get this at a third-party feed and use that as well. And then we combine this in the Skybox engine itself. The topic is also case study. How do you achieve things like compliance for you? WannaCry, SMB ports, manual project failed, okay? So what does compliance mean? Compliance means you're, as an organization, the last thing you want is that your business partner connected somewhere to your network can send spam mail out over your internet gateway. You don't want this, right? So that's a compliance rule. What you also want is to test your network against the known vulnerabilities. WannaCry was very well known, by the way, months before it was exploited in the wild. And we did know since March about it. So what we use is we use configuration policies, which means we look into, is there a default admin installed? Is there something wrong, okay? Is there something like a DHCP on the external interface turned on? UDP replay packages are being allowed for checkpoint, blah, 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 blah. So we do all this here. Then we do here the rule policy. Is there an any policy, like source defined, but then destination any, service any? You don't want this, we kick it out, we give you a red flag. And then we have the access policy. Is someone from the, let's say, delivery department, the stock department, where you get your goods in, right? Can they connect to the SAP system or the human resource system on a way they are not supposed to do that? All this is being combined in the compare engines we have, okay? And it gives you the reality of the device and the network. How does it look like? Question. Who has, if I would go into in every single organization, who could give me tomorrow morning an actual picture of his network? No one? Hands up? That's what Skybox exactly is doing. It's drawing every night a picture of your network based on the information we have, okay? Based on the information we have, it draws that picture here, and then you can query that. Here you see the WannaCry example. You see the ports of WannaCry, okay? So what we are looking here for is, from the internet, what entities, saying entities, not specific assets, are being open and exposable to these ports. And you get an answer by querying it. And that answer is, sorry, that slide is not in. That answer is either in a graphical way, or in a table way where it shows the routes, okay? And it shows you exactly which firewall allows which policy, which router contains which routers. I know we have a customer here in the room. His picture looks a little bit more difficult, right? A lot of entities here. So what you can do is to keep it a little bit more under control. This is a very small network we use for demo purposes. If you say, well, Skybox, we have something like 10,000 firewalls and routers and stuff like this. You can create here, okay, different maps based on regions, different maps based on entities, different maps based on functions. You could say, only show me network 192.168.1, or only show me web servers, or only show me New York, whatever you want to, okay? So you can break that down into parts which are more readable for people. Otherwise, it can look like a little bit like a hairball, okay? So it's getting really clogged up. Also, what we can do is we can show you, remember, we have all this, we can show you, are you PCI DSS compliant? Are you NIST compliant? Or are you compliant against your own company policy? Okay? Business partner not supposed to send emails over my internet gateway. That would be one. What are the top violating firewalls? By the way, that's the brand new web GUI. It's out since a couple of weeks. We're still extending it. We're still working on it. Okay? We're trying to get away from the old fat client. So that's the first outlook. How many violating devices you have, how many configuration checks failed, what are the top violators and stuff like this. So when you look at this, even if you click on the access policy compliance, you get a nice table showing you, well, there's no connection in between those two, but there is a connection in between those two, and you can see exactly who's violating or who's compliant to this connection. So it's a very, very quick overview here. Red, bad color, green is good. Green means compliant, red means non-compliant. So this one is bad, this is bad, this is bad. That's probably one of the bests here, okay? So it gives you a very, very quick overview. What's the current status of your compliance in your network? I told you, we're going to try to prioritize the vulnerabilities. That, up to now, that were the fundament, the basics you need to have to achieve that. When you do, remember this process here, when you want to do this, okay, you probably need to change a couple of things, how you think in your organization, right? You should not think asset. You should not think zone. You should think threat. What's a threat? A threat-centric view. So what we do here, this is SI data, security intelligence data. We have out of the dictionary here. Currently, you get a lot of stuff here. the criticality, you get the risk, you get, is there an exploit already available, you get the name of it, you get the CVE number, the asset that carries that vulnerability, how was it discovered, this was discovered by Qualys, this by the vulnerability detector. Remember the task we run every night to compare your assets against the dictionary. That is additional information about this vulnerability or currency, general stuff, the malware and exploits we're going to list here, okay? So you get everything out of a single source. Usually, for that part of the information, you're running in your organization today at least to 4 or 5 different tools. Okay, it's your patch management system, it's your asset management system, it's your vulnerability scanner, and it's probably your IPS solution. Okay, here it is out of one single source of truth. So when we have this data and we see your assets, okay, so this is basically the assets we have here, asset analyzers, so we see 914 in this case here. We also see the details about the asset, and you see there's a lot of stuff, right? I mean, simple things like, when this asset fails, how can it be attacked? When this asset fails, what impact does it have on the network? How much does it cost me when that asset fails? I'll give you one example. It's my best example. Some of you probably have heard it already. So I've been in Stuttgart with Bosch. Everyone knows Bosch, right? Do you know how many people work in Stuttgart for Bosch? You will get the number in a second. So I was doing the presentation and said, well, here's your DMZ, here's your web shop, you're selling dishwashers, you know, and hair dryers and curly makers and stuff like this. And there you have the server serving the cantina, where the employees pay cash with the lunch with the card, okay? They carry both the same vulnerability. Where do you go first? And the customer said, to the cantina. I said, oh my God, fuck. And I said, why? And he said, well, it's it's very simple math, right? He said, 25,000 people go in Stuttgart between 12 and 2 o'clock for lunch. If that system is down for an hour, 25,000 times 120 euros working time. We don't sell so many dishwashers in an hour. We don't sell so many hair dryers in an hour. And for me, that was the perfect example of what Skybox can do. In the prioritization, we could say, well, fair point. So the business value, the monetary value of this asset is much higher, and we can attach it in Skybox to the network, to this particular network, to this particular device, or to the service it carries. So if that breaks down, you see immediately the impact. So it's a very nice feature, by the way. Some people call this a pyramid. I call it the pyramid of shame. Okay? So what you see now, this is all vulnerabilities which are, well, somewhere in the world. Not so many, but close to your vulnerabilities. Okay? Keep the steps in mind. And then we have the critical severity. So the ones which are okay, we need to look at those ones. And then you go ahead and you see the ones which are critical, and they do have an exploit, which takes you to the next level of attention. And then we have the one which are already exposed. There's something to use this vulnerability. And then we have the exposed and exploited in the wild, the most critical ones. How do you break that down in Skybox? It's a very simple filter. Pyramid in action. Watch out the numbers. Something like 23,000, okay? That's what we currently carry and see in that organization. You go the next level, you say, okay, I only take the exploitable vulnerabilities here. You filter it down and it shrinks to 5,800 something. Okay? It's a better number. You apply the next filter and you say, okay, understood. Show me only the exposed ones, 425. Make sense so far? And then you apply the next filter and then you say, that's what's important for my organization. 37 vulnerability occurrences which are exposed and exploited actively in the wild. That are the ones you need to focus on. For the rest, of course, don't drop them. They shouldn't fall in between the cracks. But that are the most critical ones. That is, you remember the process, security department, IT department, that are the ones that should be on top of the queue. For the rest, of course, you need to take care, but that are the most critical ones for your organization from an organizational point of view and not from a vulnerability point of view. And that makes you better every day. Non-patch and mitigation solutions. So probably I explained the vulnerability detector already a little bit. So when we compare the dictionary against your assets and against the configurations, okay? So you can see that here, and based on that information, based on the network information, based on the firewall information we have, okay, and including this vulnerability information, we can do something what we call the Attack Explorer, okay? The Attack Explorer is a way to map vulnerabilities on top of the network. You remember the network layout I've shown you? Okay, the network map? That's the same here, but with the vulnerabilities and the attack paths. So what you see here is how someone from the internet can penetrate, okay, your network, what he can use, what kind of entities he can use to go finally to his target. And there's a big difference to your vulnerability scanner, because that's something that doesn't come out of your vulnerability scanner. The scanner here only delivers input to this, but he can't deliver that, okay? So the Attack Explorer is the way to look at it, how a hacker, a corrupted insider, a corrupted business partner, you can define the source on top, okay? How they can penetrate and attack your network. Most customers are totally surprised when we run this the first time in their network. It doesn't mean there is something going on, okay, but it at least shows the possibility. Last one, I think preventing is better than solving, right? How many of you do a risk assessment before they deploy a rule on a firewall? Hands up. No one? Okay, not a single one? So let's assume you have kind of a workflow to change firewall rules, okay? Like there's a request that comes in and it says, Carlos Heller wants to go from that source to that destination, he wants to use that service. It's a request. Then we have some technical details, we need to translate this into technical information, we need to do what we call the path identification. The path identification is in the first site independent from the security. Is there a logical way through, okay, the network? Treat it like a navigation system. You want to go from Vienna to Budapest, you start your navigation system. It first looks, is there a way at all? Do I have a map? Are there streets? And then it starts looking, what kind of streets? Is that a one-way street? Okay, and is the street blocked because of traffic? Stuff like this. And then the next step is we analyze the rules of your firewall. Then we put the security on top of it, the speed limit, so to say, okay? We look if there is already an access layer in place, yes or no. And then the magic comes together. The change manager uses the information from firewall assurance, network assurance, and the vulnerability control, and it brings it into one place. It makes the risk assessment. It tells you up front what policy violations you have. If you put this policy in place, your business partner can send spam mail from his network across yours, across your internet border. That would be a violation. Is there any vulnerability? Dear Mr. Customer, you can implement that policy, technically no problem, but at the very end, you're exposing 47 Oracle servers to the wild with their vulnerabilities. You want that? Yes or no? And then you can accept and reject, and you can do a lot of other things here. Only one thing I want to mention here is that we also do rule recertification. So once a rule is in place, we want to make sure you recertify it after 3 months, 9 months, 1 year, whatever you want. How does it look like? I call it, that's just a small object change. You need to understand, it's a modify object on this firewall. That's the object name, that are the details. So we want to add a couple of IP addresses. One would say, probably not dangerous, okay? The object is already being used, adding some IP addresses doesn't harm. Really? First of all, what you see with Skybox is the compliance violations. Okay? There will be communication in place when you apply this rule where your company says this is not compliant to the company rules. Okay? That's the first thing. You see the violations here. Object meets compliance. Object meets security. So when you apply this little object on your firewall, does it have a security impact? Who knows? In that case, you can see all of the vulnerabilities are being mapped here. Okay, so if you apply this firewall rule, all of these servers here, 240, 22, are being vulnerable, Windows, Oracle, Oracle app, Oracle whatever, against this. Okay, out of the sudden, a small object change leads to a lot of exposable vulnerabilities in your network. Then we have object meets firewall impact. How many times is your firewall administrator sitting in front of a rule change and he doesn't know which firewall it hits? Skybox compiles the request, the access change request, and it tells him exactly which firewall he should go to, what is the change, any additional details, comments, so suggested rule position, where to put the rule. Is the change required? Yes, here the change is required. Here the change is required. No, the change is already in place. Okay? How does it look like? Then again, it all comes together. We take the network map, we run the query, and we show you the path for this specific rule. It goes across the network. We show you all parties involved, routing, firewalls, layer 3 switching, yada, yada, yada. And you also can click on here, change required. On this one not, but on the one where the change is already, where no change is required, you can click on the policy and you see even the firewall rule, which already allows that request popping up from that specific firewall. A lot of stuff, huh? For 32 minutes. Sorry for doing a brain dump here. Any questions so far? No questions? Hundreds of questions. Don't be shy.
Then I think it's your turn to ask your question.
Yes. This will be my question. How does Skybox define the attack surface? Perfect.
Okay. So the prize goes to this birded person. One of them.
Thank you very much.
Thank you, Carlos, for your presentation.